Alrighty guys, so in today's lecture we're going to continue our lesson on thermochemical equations. And so what we're going to do today is we're going to learn how to find the enthalpy change like we did last time, but we're also going to learn how to do the mass of all products. You guys already know how to do this, but we're going to go over an example problem where we do both of them in the same problem. Okay? Alright, so let's start by balancing the chemical equation. Okay, we're going to have carbons, hydrogens, and oxygens on both sides of the equation, and we're just going to count up each of the elements. I have 2 carbons on the reactant side. I have 6 hydrogens because there's a 5 and there's 1 right here. And then for the oxygens, I have 1 and then 2 here, so that's going to be 3. On the right side, I have 1 carbon. Oxygens, I have 3. Hydrogens, I have 2. So it looks like my carbons are not balanced, so I'm going to have to add carbons to the product side. So if I add CO2, it's going to become 2 carbons, and then I'm going to add 2 oxygens to the product side, so this is going to go from 3 to 5. Next, I need to balance the hydrogens, and so I'm going to add H2O. If I add H2O, I've added 2 hydrogens, so it's going to go to 4. I've added another oxygen, so it's going to go to 6. But the hydrogens are not balanced yet, so I'm going to have to add another H2O. If I do that, the hydrogens go to 6, and I've added 1 more oxygen, so it goes to 7. Now, my carbons and hydrogens are good now. The issue is oxygen, so I have a choice here. I could either add C2H5OH or O2, but if I add this one, it's going to mess up all these other numbers. So I'm going to want to add O2. So if I add 1 O2, I've added 2, so it goes from 3 to 5. And so to get to 7, I would have to add another one. And there we go. We're all balanced out. Okay, so my coefficients, or the numbers that go in front, I'm going to put a 3 in front of O2 because there's 1, 2, 3. I'm going to put a 2 in front of CO2. And then for the H2O, I'm going to put a 3 in the front. And there we go. We have our balanced chemical equation. So I know that was a little bit longer, but you guys are already used to practicing longer balancing equations. Okay, next what we're going to have to do is we're going to have to calculate the enthalpy change. In order to calculate the enthalpy change, first we got to figure out our given and our end. So for our given, we start off with 25 grams of C2H5OH. Okay, so I'm going to write 25 grams of C2H5OH. We know that we're working with excess O2, so we're not going to have to worry about that. And for our end, since we're looking for the enthalpy change, we're going to be looking for the change in kilojoules. So our ending is going to be in kilojoules. Okay, from there, we can just start setting up the dimensional analysis. So I'm going to write down my given, 25 grams of C2H5OH. Going to set up my equation. My first fraction, I want to get rid of grams. So I'm going to put grams on the bottom. And I have to turn it into moles. So moles of C2H5OH. Now, if I have grams and moles on the same fraction, I know that I'm always going to get the number from the molar mass. Okay, and so I need to find the molar mass of C2H5OH. Now, C2H5OH is made out of 2 carbons. It's made out of 6 hydrogens. And it's made out of 1 oxygen. So we just go on the periodic table and we just see what we got. So carbon is 12 each carbon. So if there's 2 of them, it's going to be 24 grams per mole. Hydrogen is 1 each, so it's going to be 6 times 1, so it's 6. And then oxygen is going to be 16 each, and there's 1, so we can just do 16. So if we add them all up, we do 24 plus 6 plus 16, and that's going to get you to 46 grams per mole. That means this compound, we're going to put 46 on the bottom of the fraction, and then we're going to put 1 on top, and then the grams can cancel out with one another. Alright, and then we can set up our last fraction. We want to get rid of moles, so I'm going to put moles on the bottom. And then I'm looking for kJ, so I'm going to put kilojoules on top. And then we just look for the numbers in the balanced equation. There's no number in front of C2H5OH, so we just put a 1 on the bottom. And then for kilojoules, we see that it's negative 1368, so we're going to put negative 1368. the moles are going to cancel, and then there you go. You can start calculating this out. So we're going to go on our calculator. We're going to start with the number on top, 25, divided by the bottom, multiplied by the top. So 1368. But we also need to make sure that it's negative. So the final answer for this part of the problem is going to be negative 743.478 kilojoules. Okay, so that means for the first part of the equation, it's going to be negative 743.478 kilojoules. Now, since it's negative, we know that this is an exothermic reaction, which means that energy is released. Okay, so energy is released. All right, so that was part one, the first part where we just find the enthalpy change. Now we can move on to part B, and for part B, we need to find the mass of all the products. Now, this is something that we've done before, so if you feel pretty confident trying this out on your own, you guys can pause the video and check your answers at the end. But if you're still a little bit uncomfortable, since this is a new type of equation, we can go over it step by step. But it's pretty much the same thing that we've been doing. So the given is still the same here. The given is still 25 grams of this compound, but we just need to find the mass of all products. So products are chemicals on the right side of the equation. So the right side of the equation has CO2 and H2O, so we're going to have to do a stoichiometry problem for that one and the stoichiometry for that one. So that's going to be our two ends. We have two different endpoints. Okay, so we're going to start off with the CO2. Now, when we're looking for the mass of the products, we're just going to use gamma, so grams, moles, moles, grams. So we're going to start with 25 grams of C2H5OH. We're going to set up a fraction. We're going to set up three fractions. Okay, and the top's going to be gamma, so grams, moles, moles, grams. We know that the first two, or the tops of the first two, have to be about the same chemical, so it's going to be C2H5OH on the first two. And then we're looking for CO2, and the last two fractions are going to have the same on the top. So it's going to be CO2 on the last two. All right, from there, we can start filling in the fraction. So we're going to put grams of C2H5OH on the bottom. Since it's grams and moles on the same fraction, we're going to get the numbers from the molar mass. Okay, we said earlier that the molar mass of C2H5OH is 46 grams per mole, so it's 46 on the bottom, 1 on the top, and that's going to let me cancel out my grams of C2H5OH. Now I want to get rid of moles of C2H5OH, so I'm going to put moles on the bottom. Since we have moles and moles on the same fraction, the numbers are going to come from the balanced equation. So if we look for CO2, there's a number 2 in the front, so we'll put a 2 in the front. C2H5OH has a 1 in the front, so we're just going to put a 1 on the bottom, and then moles can cancel out. Now I want to get rid of moles of CO2, so I'm going to put moles of CO2 on the bottom. Since there's grams and moles on the same fraction, we're going to get the numbers from the molar mass. Okay, for the molar mass of CO2, there's 1 carbon, and that's going to be 12. There's 2 oxygens. Oxygen is 16 each, that's 32. So if we put them together for CO2, we're going to get 44. So it'll be 44 grams, and grams is on top, per mole. So it's 1 on the bottom. And then from there, we can cancel out the moles, and then we can just plug and chug this into our calculator. So tops divided by bottoms. So we start with 25. We divide it by 46. And then we multiply that by 2 on the top, multiply that by 44, and then we're going to get a final answer of 47.826 grams of CO2. So this is going to be the first product. Okay? So the first product is 47.826 grams of CO2. Now we need to do it for the other product, which is H2O. So we're going to calculate for H2O. Same thing here. We're going to start off with 25 grams of C2H5OH. We're going to set up 3 fractions. And then we're going to do gamma again. So grams, moles, moles, grams. And so we know that the first two have to be about the same chemical, so C2H5OH. And then the last two are going to be about what we're looking for, which is H2O. So we're going to put H2O on the last two. All right, so we're going to try to get rid of grams of C2H5OH. And since it's grams and moles on the same fraction, again, we're going to get the numbers from the molar mass. And we found this already 2 times. So it's going to be 46 grams per mole. And then the grams can cancel out. We want to get rid of moles of C2H5OH. So we're going to put moles on the bottom. We're going to get the numbers from the balanced equation. So same thing, C2H5OH is still a 1. H2O is 3, and then the moles can cancel out. And then lastly, we can put moles of H2O on the bottom. And then since the numbers come from, or the fraction has grams and moles on it, we're going to get the numbers from the molar mass. There's 2 hydrogens, which is 2. And then there's 1 oxygen, which is 16. So you put them together, and you should get 18 grams per mole for H2O. So 18 grams per 1 mole, and then we can cancel these out. And then from there, we just need to calculate it out. So 25 divided by 46 times 3 times 18, and you should get a final answer of 13.043. Okay, so 13.043, and the units, grams of H2O. All right, there you go, and we're all done. So basically, the calculating the mass of all products, we've been doing this for basically 4 or 5 months now. It's just regular stoichiometry. And the enthalpy change is the same thing that we did in the previous lesson. And for your questions on your assignment today, it's going to ask you, hey, is it exothermic or is it endothermic? If the enthalpy change, the triangle H is negative, it's going to be exothermic. So this one was exothermic. And if it's exothermic, energy is released. So that's going to be how you find the answers for that part of the problem. Okay, but other than that, hopefully that was helpful. Let me know if you guys have any questions, and I'll give you the rest of the class period to finish that assignment.